So in this question, we're asked to use the data in the table to estimate the slope at 2.25. So to estimate the derivative, we're going to use the two closest points on the table to approximate by using the average rate of change. So how should we answer? Let's say f prime of 2.25 is approximately, don't forget to use the squiggly equals, we're going to say f of 2.5 minus f of 2 over 2.5 minus 2. Now remember to use the 2 points right next to the point that they give you. If you use any other points, they probably won't give you credit. So let's go ahead and plug in the points from the table. F of 2.5 is 10, f of 2 is 6, and then over 2.5 minus 2. Now if you don't want to simplify, you don't have to, because as long as your number is numerically equivalent, you're fine. Since this is the calculator section, you can go ahead and do that. So this is going to be 4 over 0.5, and that simplifies to 8. Now in terms of units, what should we do for units? Well, the top is measured in milligrams per square centimeter, and then the bottom is our x value, or our r value here, and that's measured in centimeters. When you take these two units and divide them by each other, you get milligrams per centimeters cubed, or you can say milligrams per square centimeter per centimeter. Either one should be acceptable. And now we need to interpret what this means in terms of our question. When the radius is 2.25 centimeters, the density of the bacteria population is increasing at approximately 8 milligrams per cubic centimeter. Now, how many points do I think this would get? I think this would get 2 points. I think you get 1 point for your correct answer with units, and I think you get 1 point for your interpretation. So part B of this question asks us to find the total mass in milligrams of the bacteria in the petri dish, and they want us to evaluate this gnarly integral. It looks like something that you probably haven't done in class, but then you see the phrase right Riemann sum, so maybe this is something that we can do, right? So normally when I get a question like this, I start off by drawing a sketch of the graph. So I'm going to explain this question by doing it as if it were a normal Riemann sum, right? So if it were a normal Riemann sum and we want to do a right Riemann sum, this is basically, we're going to take a bunch of the rectangles, right? So these are the heights of the rectangles, and the dx represents the width of these rectangles. And if we were just to do a normal Riemann sum, the rectangles would look like this. So we could approximate this by just saying, okay, well, what's the width? The width there is 1 times the height. We're using the right Riemann sum, so we take the right bound. The next width is also 1. 2 minus 1 is 1 times 6. This width is slightly different, so this is 1/2. And then this width is 1.5. So then what are we doing differently now, though? So we're going to add a few more things. We're going to put this 2 pi coefficient in front. And then the other thing that's slightly confusing is now they put this r value here. So r times f of r dr. So all this stuff here is the same as we did before, but now as we're multiplying it by r, that's like saying we're going to take the x value at each of these points and multiply each of our Riemann sum by how long this x interval is. So in front of this one, we're going to put in a 1 for that x value. So it's 1 times 1 times 2. For the next one, the r value is 2. So we're going to use the right one, right? We have a choice between the left bound and the right bound, and here we're going to choose the right bound every time we have an interval. So it'll be 2 times 1 times 6. This would be 2.5 times 1/2 times 10. And it'd be 4 times 1.5 times 18. And so for those of you who've done shell method, this is a version of the shell method, right? This equation actually gives you the volume of the cylinder if you were to rotate it around a axis that's parallel to these slices. So again, as long as you have the mathematically equivalent answer, you can leave it like this. So notice that I have this 2 pi out in front, and I forgot to leave it here, so I'm going to put this parentheses around here and do a 2 pi out in front. And then since this is the calculator section, I did plug it into my calculator. So the answer is 269 pi milligrams. How would I award points? Well, it says use a right Riemann sum, so I think anything that indicates that you are setting up a right Riemann sum should get a point. Something along these lines to show that you're using these numbers. I think you'd get another point for actually using the x values, because that part is completely confusing there to add these numbers in. And then I think the third point you get is for the mathematically equivalent answer. So part C asks if the approximation we found in the last part is an overestimate or an underestimate. So as we plotted the points, right, we saw that the points were indeed increasing from before. And then, so what does the question tell us about the graph? It tells us that the function is an increasing differentiable function. So if it's an increasing differentiable function, maybe the function would look something like this. We don't know that it's linear, but I'm just doing this for an example. And then whenever you use a right Riemann sum, notice that whenever I draw my rectangles, the rectangles are always sticking slightly above the curve. So the rule is whenever you have an increasing function and it's differentiable and continuous, then a right Riemann sum is an overestimate. Because f of r is increasing, a right Riemann sum will provide an overestimate. And then I think since this is a pretty straightforward question, this would earn only 1 point. So part D gives us the density function of the bacteria in the petri dish. So I went ahead and plugged this into my calculator. And it says for what value of k, where k is between 1 and 4, is g of k equal to the average value of g of r on the interval. So when they want the average value of the function, we're going to integrate from the bounds, so 1 to 4, of that function. So this gives us the total value, but then if we want the average value, we go ahead and times it by 1 over 4 minus 1, or basically we're dividing it by the width of the interval there. So when I plug this into my calculator, I got 9.876. Two things to remember here. Remember always 3 decimal places and always in radian mode. So this is the average value. So then once you get the average value, you're going to plug this into your calculator and graph it. I'm not going to do that right here. But basically when you set y1 equal to this one and then set y2 equal to this one, you find where those 2 points cross on the graph. And when I did that, I got that the point of intersection was 2.497. Now, how do you show that when you're doing work? You just say g of k equals 9.876 when k equals 2.497. There's not a lot of work to show here because they know this is a calculator active question. I think this question would be worth 2 points. 1 point for showing that you know what the average value is and getting the right answer, and then 1 point for getting the actual point of intersection also. Now that I've finished recording this video, I realized that I only awarded 8 points out of a total possible 9 points. If I had to make a guess, I'd guess that part B would be worth 4 points instead of the 3 that I awarded. I'm not sure where that extra 4th point would come, but right now the graders aren't even sure either because they don't figure out how the points are distributed until they're sitting in front of the test and grading them. If you have any thoughts or comments on where that extra point could come from, feel free to leave a comment below. Also, if you really enjoyed this video and found it helpful, please like the video or subscribe to our channel so I can keep making content like this.